Download this code from codegive.com, link in the description below. OK, let's dive deep into Unicode, a fundamental concept in modern programming. We'll explore what it is, why it's essential, and how to work with it in code, covering practical examples and common scenarios. We'll aim to demystify Unicode and equip you with the knowledge to handle text correctly in your applications. The Mystery of Encoding, a history lesson. Before Unicode, we lived in a world of chaotic character encodings. Think of encoding as a translation table. It tells the computer how to represent characters, letters, numbers, symbols, as numbers that it can store and process. Different encodings existed for different regions and languages. ASCII, American Standard Code for Information Interchange, the most basic. It used 7 bits to represent 128 characters, including uppercase and lowercase English letters, numbers, punctuation, and control characters. Perfect for basic English, but completely inadequate for anything else. Extended ASCII used 8 bits, 256 characters. Still didn't solve the problem completely, as different extended ASCII code pages assign different characters to the values 128 to 255. Windows 12.52, Latin 1, was a common one in Western Europe, but it wasn't compatible with other encodings. The problem was that if you opened a text file created with one encoding using a program that assumed a different encoding, you'd get gibberish. For example, a French text file with accented characters might appear as random symbols in an English-only program. This was incredibly frustrating and a major source of bugs. Unicode, the universal solution. Unicode emerged as a revolutionary attempt to solve this problem once and for all. The goal to assign a unique number, called a code point, to every character in every language, as well as common symbols. The basic idea. Unicode is a huge table. Think of it as a giant book with characters assigned a page number. The page number is the code point. Key concepts. Code point. The numerical value assigned to a character in Unicode. It's represented in hexadecimal with the prefix U+. For example, the letter A has the code point U plus 0041, and the smiley face grinning face with smiling eyes has the code point U plus 1F604. Character encoding, Unicode transformation format. How those code points are actually represented in bytes for storage and transmission. Unicode itself doesn't specify how to store the code points, the encoding does. The most common Unicode encodings are UTF-8 *, a variable width encoding. Uses 1 to 4 bytes to represent a character. ASCII characters are encoded using a single byte, identical to ASCII. This makes UTF-8 very efficient for text that's mostly English. It's the dominant encoding on the web and in many modern systems. UTF-16 * uses 2 or 4 bytes to represent a character. More space efficient than UTF-8 for languages with many characters outside the ASCII range. However, it has NDNS issues, byte order, which can cause problems if not handled carefully. UTF-32 uses 4 bytes to represent every character. Simple but wastes space if most of your text is ASCII. Why Unicode matters, beyond just making text readable. Globalization enables your applications to support multiple languages without encoding conflicts. Essential for reaching a wider audience. Data integrity. Ensures that data is stored and retrieved correctly, regardless of the user's language or regional settings. Search and sorting. Allows accurate searching and sorting of text across different languages. Asterisk security asterisk correctly handling Unicode helps prevent security vulnerabilities related to encoding errors. Working with Unicode encode, Python examples. Python 3 has excellent Unicode support. Let's look at how to work with Unicode strings. 2. Encoding and decoding. Asterisk encoding asterisk converting a Unicode string, Python str type, into a sequence of bytes using a specific encoding, example UTF-8. Asterisk decoding asterisk converting a sequence of bytes, Python bytes type, into a Unicode string. Important notes on encoding/decoding asterisk. Asterisk explicit encoding/decoding is key asterisk always specify the encoding when encoding or decoding. Never rely on the system's default encoding, as it can vary. This is a common source of bugs. Asterisk Unicode encode error asterisk occurs when you try to encode a Unicode string using an encoding that can't represent all of its characters. For example, trying to encode cafe using ASCII will raise this error because the E character is not in the ASCII character set. Asterisk Unicode decode error asterisk occurs when you try to decode a sequence of bytes using the wrong encoding, and the byte sequence doesn't conform to the expected encoding rules. This often leads to gibberish. 3. Reading and writing files with Unicode. Key points when working with files asterisk. Asterisk encoding parameter asterisk crucially, the open function takes an encoding parameter. Always set this parameter to the correct encoding when reading or writing files containing Unicode characters. UTF-8 is a good default choice for general compatibility. Asterisk without the encoding parameter asterisk if you omit the encoding parameter, Python will use the system's default encoding, which might not be UTF-8, leading to potential encoding problems. 4. Unicode normalization. Sometimes, the same character can be represented in multiple ways in Unicode. For example, E can be represented as a single code point, U plus 00E9, or as a combination of E, U plus 0065, and a combining acute accent, U plus 0301. Asterisk normalization asterisk the process of converting different representations of the same character to a consistent form. This is essential for accurate string comparisons and searching. Python's Unicode data module provides tools for Unicode normalization. Normalization forms asterisk. Asterisk NFC, normalization form canonical composition the most common form. Combines precomposed characters, like E, where possible. Asterisk NFD, normalization form canonical decomposition decomposes characters into their base character and combining characters. Asterisk NFKC, normalization form compatibility composition similar to NFC, but also replaces compatibility characters, characters that have similar meanings but different forms, with their preferred equivalents. Asterisk NFKD, normalization form compatibility decomposition decomposes characters and replaces compatibility characters. 5. Unicode and web applications. Asterisk HTML asterisk always specify the character encoding in your HTML documents using the meta tag. Asterisk HTTP headers asterisk the content type header in HTTP responses should also specify the character encoding. Asterisk databases asterisk configure your database connections and database tables to use UTF-8 as the character encoding. 6. Best practices for Unicode handling. Asterisk know your data asterisk determine the encoding of any external data you're working with, files, network streams, etc. Asterisk be explicit asterisk always specify the encoding when encoding or decoding. Asterisk normalize when necessary asterisk use Unicode normalization when comparing or searching text to ensure accurate results. Test thoroughly. Test your applications with a variety of Unicode characters and languages to identify and fix any encoding issues. Consistent encoding. Use UTF-8 consistently throughout your application, database, files, network. 7. Common mistakes and troubleshooting. Unicode encode error. ASCII codec can't encode character. This usually happens when you're trying to encode a Unicode string using the default ASCII encoding, which only supports 128 characters. The fix is to explicitly encode using UTF-8, or another appropriate encoding. Garbled text. This is almost always caused by using the wrong encoding when decoding. Check the encoding of the data source and use the correct encoding when decoding. Ignoring the encoding parameter. Forgetting to specify the encoding parameter when opening files is a very common mistake. Mixing encodings. Be careful when combining data from different sources that might use different encodings. Convert all data to a consistent encoding, usually UTF-8, before processing. Example of encoding and decoding with error handling. In summary, Unicode is a cornerstone of modern software development. By understanding how Unicode works and following best practices for handling it, you can create robust, globalized applications that correctly process text in any language. The key is to be explicit about encodings, normalize when necessary, and test thoroughly. Don't let the mystery of Unicode keep you up at night.